Imagine waking up one morning to an Earth completely transformed. The oceans, which span more than 70% of the planet's surface, have frozen solid overnight. This isn't just a simple wintertime freeze, it's an apocalyptic transformation, with far-reaching consequences. To truly grasp how life on Earth would change under these circumstances, we need to start by understanding the vital role oceans play in maintaining our planet's delicate balance. The oceans are far more than vast bodies of water. They are the engine that keeps our planet alive. By absorbing and redistributing heat from the sun, oceans regulate global temperatures and drive weather patterns. Without them, the Earth's climate system would be thrown into chaos. Their currents act like conveyor belts, moving warm water from the equator to the poles and circulating colder water back. This continuous motion ensures relatively stable temperatures around the globe, allowing ecosystems to thrive. If all the oceans froze overnight, this heat distribution would stop immediately. The equator, no longer cooled by ocean currents, would become unbearably hot. Meanwhile, regions farther from the equator would experience extreme and relentless cold. Weather patterns that we've come to recognize, such as predictable rain seasons or coastal breezes, would vanish, replaced by erratic and destructive storms. The visual of frozen oceans alone is enough to inspire awe and dread. From horizon to horizon, sheets of ice would stretch endlessly, reflecting sunlight instead of absorbing it. This would accelerate global cooling, as ice is far more reflective than water. Known as the albedo effect, this feedback loop could quickly plunge the planet into a deep freeze, turning even the most temperate regions into icy wastelands. One of the first and most profound impacts of frozen oceans would be on marine life. Oceans are teeming with biodiversity, from microscopic plankton to massive whales. These organisms depend on liquid water for survival. Plankton, which form the base of the oceanic food chain, would vanish almost immediately, triggering a cascade of extinctions. Marine ecosystems, built over millions of years, would collapse in an instant. In addition to marine life, the freezing of the oceans would directly impact the air we breathe. Phytoplankton, tiny organisms that live near the ocean's surface, produce about half of the oxygen in Earth's atmosphere through photosynthesis. With the oceans frozen and these organisms wiped out, oxygen levels would begin to decline, making survival even more challenging for land-dwelling creatures, including humans. This chilling scenario of frozen oceans sets the stage for even greater challenges that humanity would face. In the next part, we'll explore the domino effect this event would have on human societies, economies, and the planet's ecosystems. From food supply chains to the collapse of global trade, the repercussions of this catastrophic event would redefine life as we know it. With the oceans frozen solid, the cascading effects on human society would be nothing short of catastrophic. Almost overnight, the systems and infrastructure we rely on daily would begin to unravel, leaving humanity in a state of unprecedented crisis. Let's delve deeper into how this frozen world would transform our lives in ways we've never imagined. One of the immediate consequences would be the collapse of the global food supply. Oceans are not only home to marine life, but also a cornerstone of human sustenance. Over 3 billion people worldwide depend on seafood as their primary source of protein. Entire fishing industries would be obliterated, leaving communities that rely on the ocean for food and livelihood in desperate circumstances. But the impact doesn't stop there. Ocean-based economies, which include industries like tourism, shipping, and aquaculture, contribute trillions of dollars annually to the global economy. With the oceans frozen, these industries would grind to a halt, leading to mass unemployment and economic collapse. Global trade, which relies heavily on ocean transportation, would face an unprecedented crisis. Over 90% of the world's goods are transported by sea, from essential food and medical supplies to raw materials used in manufacturing. Without navigable oceans, ships would remain immobilized in ports, causing supply chains to fracture. Nations that rely on imports to sustain their populations would face severe shortages of essential goods, plunging millions into poverty and hunger. As if these challenges weren't enough, the Earth's climate would spiral into further chaos. With the oceans frozen, the planet's ability to absorb and moderate carbon dioxide levels would cease entirely. The oceans currently act as one of the largest carbon sinks, absorbing nearly 1/3 of all human-produced carbon dioxide. Without this mechanism, greenhouse gases would remain trapped in the atmosphere, amplifying the effects of climate change. Paradoxically, while the surface would freeze, atmospheric conditions could become increasingly volatile, with extreme storms and weather anomalies wreaking havoc across the globe. This drastic change would also disrupt freshwater availability. Over 2/3 of the Earth's freshwater supply is tied to the hydrological cycle, which depends on the continuous evaporation and precipitation facilitated by oceans. A frozen ocean would halt this cycle, leading to severe droughts in some regions and devastating floods in others, as weather patterns shift unpredictably. Major rivers and lakes that rely on consistent precipitation would dry up, further threatening water supplies for drinking, agriculture, and industry. In this frozen reality, life for humans would become increasingly fragile. Crops would struggle to grow in the harsh new climate, and the soil, deprived of consistent moisture, would lose its fertility. Agricultural yields would plummet, and nations around the globe would face widespread food shortages. Social unrest would likely erupt as communities fought over dwindling resources, leading to instability and conflict on a global scale. The interconnectedness of our world means that a frozen ocean would ripple through every aspect of life, revealing just how much humanity depends on the stability of our planet's natural systems. As we've now explored the immediate societal impacts, the next part will delve into the long-term environmental changes and the grim reality of adapting to a planet where the oceans remain frozen. The long-term environmental impacts of frozen oceans would reshape Earth into a world nearly unrecognizable from the one we know. Over time, the planet's ecosystems and climates would adapt, or collapse, under the weight of this unprecedented change, setting off a chain reaction of consequences that would ripple through every aspect of the natural world. Let's explore how life on Earth would attempt to survive and the new challenges that would arise. A critical issue would be the disruption of the ocean's role in regulating the planet's temperature. In our current world, ocean currents act like massive conveyor belts, moving warm water from the equator toward the poles and colder water back toward the equator. This system, called thermohaline circulation, helps stabilize global temperatures. Without liquid oceans, this essential process would stop entirely. Regions near the equator would become unbearably hot, while areas closer to the poles would sink into perpetual deep freeze. This stark temperature divide would make large parts of the planet uninhabitable for both humans and wildlife. The extinction crisis that began immediately after the oceans froze would intensify over the years. Entire marine ecosystems would have already been wiped out, but the absence of these ecosystems would start to affect terrestrial life as well. Coastal habitats, which support diverse wildlife and vegetation, would be obliterated as frozen oceans encroach on land. Species that depend on these habitats, from seabirds to coastal predators, would face extinction without access to food or viable nesting areas. The loss of biodiversity would create ripple effects throughout the food web, destabilizing ecosystems on a massive scale. On land, ecosystems would struggle to adapt to the new climate conditions. Forests, grasslands, and wetlands are all intricately linked to the water cycle, which would be profoundly altered by the absence of liquid oceans. Rainfall patterns would become erratic and extreme, creating vast deserts in some regions and excessive flooding in others. Vegetation that depends on consistent rainfall, like crops and forests, would begin to die off, leading to soil erosion and desertification. The loss of plant life would reduce the planet's ability to absorb carbon dioxide, further exacerbating atmospheric instability. The frozen oceans would also create physical challenges for the planet itself. Ice expands as it forms, so the vast expanses of frozen water would begin exerting immense pressure on the Earth's crust. This could lead to an increase in seismic and volcanic activity as the planet adjusts to the added stress. Earthquakes might become more frequent and more severe, while dormant volcanoes could erupt unexpectedly. These geological events would add yet another layer of destruction to an already struggling world. Human attempts to adapt would bring their own set of challenges. As the frozen oceans created a landmass of ice, nations might try to exploit this new terrain for resources. However, any attempts to drill or mine beneath the ice would be fraught with danger. The unstable environment, combined with the difficulty of operating in extreme cold, would make such endeavors costly and hazardous. Additionally, competition for resources could lead to conflict, as countries vied for control over whatever scarce materials were left. One of the more chilling possibilities is the feedback loop created by the frozen oceans. As the ice reflects sunlight back into space, the planet would continue to cool. This could plunge Earth into a snowball state, where even land masses would freeze over, leaving only a thin band near the equator habitable for life. In such a scenario, surviving species, if any, would be forced to adapt rapidly or face extinction. Humanity would need to retreat to this narrow strip of land, relying on technology and ingenuity to eke out a precarious existence. In this frozen world, the concept of seasons would largely vanish. With no ocean currents to drive the cycle of warm and cold, many regions would be locked in unchanging climates. This would have far-reaching effects on agriculture, migration patterns, and even human culture, which has been shaped for millennia by the changing of the seasons. As we look at these grim possibilities, it's clear that the frozen oceans would not only alter life as we know it, but also challenge the very essence of survival itself. In the final part, we'll examine the ultimate fate of this frozen Earth, the potential for recovery, and whether humanity and the planet could ever find a path back to stability. As centuries pass on this frozen Earth, the chances of recovery grow slimmer, and humanity's attempts to adapt become increasingly desperate. The frozen oceans, once vital to the planet's stability, have created an unrelenting and hostile environment. The very essence of Earth's ecosystems has been fundamentally altered, and the possibility of returning to the world as it once was seems more like a distant memory than an achievable reality. One of the most pressing challenges would be humanity's search for sustainable energy. With frozen oceans cutting off access to offshore oil and gas reserves, alternative energy sources would need to be developed and expanded rapidly. Solar power, while viable in equatorial regions, would struggle in areas locked in perpetual cold and cloud cover. Wind energy could offer some relief, but the extreme weather conditions would make maintaining turbines nearly impossible. Efforts to harness geothermal energy might increase, but such ventures would remain limited to specific regions, creating disparities between nations with access to resources and those without. Survival would also hinge on humanity's ability to engineer new agricultural systems. Traditional farming methods would be rendered obsolete as arable land continues to shrink under extreme conditions. Innovations like vertical farming, hydroponics, and lab-grown food would dominate. But these systems require immense energy and technological infrastructure. Many nations would lack the means to implement these solutions, creating a divide between technologically advanced societies and those left behind to fend for themselves. With the oceans now a vast frozen expanse, travel and communication would also evolve in unprecedented ways. Air travel would remain possible, but would require vast amounts of energy and resources. Overland routes across the ice might develop, but they would be fraught with dangers like crevasses and unpredictable ice shifts. In the harshest climates, humanity might retreat into enclosed cities or underground habitats, designed to protect inhabitants from the freezing temperatures and the instability of the surface. Meanwhile, the natural world would continue its slow, silent transformation. In some places, life might adapt to the cold in unexpected ways. Species capable of surviving in extreme conditions, such as microorganisms and cold-adapted insects, could thrive, gradually filling ecological niches left vacant by the disappearance of larger organisms. Over time, entirely new ecosystems could emerge, ones built around the unique challenges of a frozen planet. These new forms of life would bear little resemblance to what once existed, representing a stark reminder of how profoundly the planet has changed. The psychological toll on humanity would be immense. Generations born into this frozen world would know nothing of liquid oceans, green fields, or temperate climates. Cultural expressions would shift to reflect the new reality, with art, music, and literature depicting themes of survival and endurance rather than the natural beauty of a world that no longer exists. Over time, collective memory of Earth's former state might fade, leaving only fragmented stories of a time when the planet was warm and vibrant. Despite these challenges, humanity would likely continue to search for solutions. Scientific efforts might focus on reversing the freeze, using advanced technologies to melt the ice and restore the oceans. However, such attempts would face monumental obstacles, not least the sheer scale of the frozen expanse. Even if technology advanced enough to begin the process, the timeline for success would span centuries or even millennia, far beyond the lifespan of any single generation. The Earth itself, in its frozen state, might stabilize eventually, but at great cost. A frozen planet could sustain some form of life, but it would be a shadow of what once existed. In this stark new reality, humanity's ingenuity, resilience, and ability to adapt would be tested like never before. Whether we would rise to the challenge or succumb to the harshness of this frozen world remains an open question. And so the story of frozen oceans is not just a tale of environmental collapse, but also a testament to the fragile balance of life on Earth. It serves as a reminder of the interconnectedness of our planet's systems and the need to protect them for future generations. Did you know that the 2017 Greenland tsunami was triggered by a massive glacier collapse, sending waves over 90 feet high crashing into the coastline? This massive event, which happened on June 17th, 2017, is one of the rare occasions where such a destructive natural disaster was caught on camera. The footage is breathtaking and shows the immense power of nature, reminding us just how fragile our planet can be. The incident took place in the Karat Fjord, a remote part of western Greenland. Greenland is home to the world's second largest ice sheet, which is over 3 kilometers thick in some places. This massive ice sheet has been shrinking rapidly over the past century, mainly due to rising temperatures. The ice loss is accelerating, and the result is something we're only starting to understand. The loss of ice leads to the collapse of glaciers, creating a dangerous ripple effect that can cause catastrophic events. In the case of this tsunami, the glacier that collapsed had been rapidly melting and breaking off into the fjord, adding pressure to the ice and ultimately causing the dramatic collapse. The tsunami itself was not caused by an earthquake, as most tsunamis are. Instead, it was triggered by the sudden and violent collapse of a section of the glacier into the fjord. When a large section of ice breaks off from the glacier, it can displace a significant amount of water. This displacement generates a huge wave, which in this case surged over 90 feet high. The enormous wave quickly moved toward the shore, sending water crashing into the surrounding coastline. Although the event occurred in a relatively remote area, the power of the tsunami was still strong enough to be recorded and studied by researchers who happened to be in the area at the time. This moment, captured on film, serves as a reminder of the terrifying power that nature can unleash. It also highlights just how vulnerable areas like Greenland are to the effects of climate change. Rising temperatures are melting the glaciers at an alarming rate, and these massive ice sheets are contributing to the rising sea levels we've been hearing about for years. When ice sheets melt and glaciers collapse, they don't just contribute to sea level rise, they can trigger other catastrophic events, like this one. The 2017 Greenland tsunami is just one example of how our changing climate is leading to increasingly extreme and dangerous natural disasters. The wave itself was incredibly dramatic. The scientists who filmed it were able to capture not just the size of the wave, but also the sense of how quickly it came crashing down. The image of that giant wall of water moving toward the shore, with plumes of water rising into the air, is unforgettable. It's a terrifying reminder that no matter how much we may think we control our environment, nature is still in charge, and sometimes it has the power to reshape everything in an instant. So, what exactly happened in Greenland that day, and what caused the glacier to collapse? The ice sheets in Greenland have been under stress for a long time. As the temperatures rise, the ice sheet begins to melt, weakening its structure. In the case of the Karat Fjord, a piece of the glacier became unstable, and it eventually cracked and fell into the fjord. This sudden release of ice caused the displacement of water, which created a wave so large that it crashed into the shoreline with unimaginable force. Though this was a relatively isolated area, the scale of the event makes it a warning sign of how climate change could affect coastal communities in the future. The fact that this event was caught on camera is one of the rare opportunities we have to witness nature's power in such a dramatic way. While this tsunami did not cause significant loss of life, it serves as a stark reminder of the dangers that climate change and glacial activity can bring. In the coming parts, we'll explore how the tsunami impacted the region, the aftermath, and the lasting effects of this event on our understanding of climate change's potential to create such sudden and severe natural disasters. The Karat Fjord tsunami on June 17, 2017 was a stark demonstration of the overwhelming force nature can unleash. What made this event even more remarkable was the rarity of such occurrences. While tsunamis are often associated with earthquakes, this one was triggered by the collapse of a massive glacier, which is an event that doesn't happen every day. The glacier's collapse created an enormous wave, sending it barreling toward the coast at a speed and size that was beyond comprehension. Scientists, researchers, and residents in the area witnessed something that few people ever experience firsthand: a natural disaster of this scale and power. The real story here isn't just the tsunami itself, but the warning signs that preceded it. For years before the collapse, the ice sheet in Greenland had been melting at an accelerated rate. This rapid melting isn't just a phenomenon we're seeing in Greenland, it's part of a much larger pattern of global warming and climate change. As the temperatures rise, glaciers, which were once stable, begin to break apart and release huge chunks of ice into the surrounding waters. This process, known as calving, is not unusual, but the scale at which it occurred in this instance was beyond what most experts anticipated. What set the 2017 Greenland tsunami apart from others was the sheer size of the glacier collapse. The Karet Fjord, where the glacier had been slowly eroding, became the site of one of the most dramatic natural events in recent history. The collapse of the glacier was so sudden and violent that it displaced a huge volume of water, which led to the creation of a giant wave. This tsunami was so powerful that it reached up to 90 feet in height. The size and speed at which it traveled is a reminder of just how quickly natural disasters can strike, especially when driven by larger environmental factors like the melting ice sheets. While the tsunami did not cause fatalities, it was a wake-up call. It's one thing to hear about the melting of the Greenland ice sheet or the rising sea levels, but it's another thing entirely to see the immediate effects of those changes in real time. This wasn't a slow-moving crisis. This was something sudden and uncontrollable. The collapse of the glacier, followed by the formation of a massive tsunami, showed just how fragile our coastlines are. The event underscored the dangers coastal communities face due to the effects of climate change and how rapidly things can go from a minor event to something devastating. Scientists who were working in the area that day were fortunate to capture this extraordinary moment on film. The footage not only allowed us to witness the power of the wave, but also gave us a glimpse into the forces of nature that we often overlook. Seeing a glacier collapse in real time, followed by a tsunami crashing against the shore, provided an unparalleled perspective on the vulnerability of areas like Greenland to the changes caused by global warming. It's these types of events that serve as a visual reminder of the broader environmental challenges we face as a planet. Greenland's ice sheet has been shrinking for decades, but the events of June 17, 2017 made it painfully clear just how severe the consequences of this shrinking are. The aftermath of this tsunami was immediate and violent, but its long-term effects may be even more profound. As more glaciers continue to collapse and ice sheets melt, the world will be faced with a rising number of unpredictable and catastrophic events, from larger waves and stronger storms to increasingly devastating natural disasters that affect not just remote regions but coastal cities around the world. The Greenland tsunami stands as a symbol of the kind of dangers we will increasingly face in the years to come if we don't take action. But what can be done to stop the process? Scientists and experts are continually studying these changes, seeking ways to predict such events and protect vulnerable communities. The solutions aren't easy, and they require global cooperation. But understanding the causes, the impacts, and the magnitude of such events is the first step toward addressing the wider climate crisis, and ensuring that future generations don't have to live through the devastating consequences of a rapidly changing world. The immediate aftermath of the June 17, 2017 tsunami in Greenland was both breathtaking and terrifying. The wave, with its massive force, reshaped the landscape of the Karet Fjord in ways that were hard to comprehend. While the event itself was over in a matter of minutes, the damage it caused would last for much longer. It wasn't just the destruction of the glacier itself. The real devastation came from the massive wave it created. As it crashed into the coastline, it left behind a scene of complete destruction. In the hours after the tsunami, the coastline was left in a state of disarray. Huge chunks of ice that had broken off from the glacier were scattered all along the shore. Rocks, trees, and debris were tossed around, some carried far from their original locations. The violent force of the wave had reshaped the coastline, washing away anything in its path. It wasn't just the physical destruction that was concerning. The event also revealed the delicate balance of the area's ecosystem. The fjord, which was home to a variety of wildlife, had been disturbed. The turbulent waters displaced marine life and caused irreversible damage to the natural environment. As the waves receded, it became clear that this was a dramatic reminder of how quickly nature can change, how fragile our ecosystems are, and how easily they can be disrupted by even a single catastrophic event. Though the immediate impact was catastrophic, the tsunami also served as an environmental warning. The glacier that collapsed, sending the huge wave crashing toward the shore, had been melting at an accelerating rate. This wasn't just an isolated incident, it was a small glimpse into the future of what could happen if global warming continues to progress at its current pace. If these glacial collapses become more common, the number of such tsunamis may rise, leading to even greater destruction in coastal areas. The loss of ice from the Greenland ice sheet has already contributed to rising sea levels, which in turn has made coastal communities more vulnerable to storms and flooding. This particular event was like a microcosm of the much larger challenges that lie ahead if nothing is done to slow the effects of climate change. The fact that the tsunami in Greenland occurred in a remote area where human life was not lost was in many ways a small blessing. However, the power of this natural disaster made it clear that it could happen anywhere. Coastal communities around the world, particularly those in low-lying areas, are at risk of similar events if the glaciers continue to melt at this alarming rate. It's a reminder that, although these events are still rare, their potential to cause widespread damage is significant. As we learn from these events, it's essential that we invest in understanding the science behind glacial activity and tsunamis and how we can better predict and prepare for such disasters in the future. In the days and weeks following the tsunami, researchers from around the world flocked to the area to study the impact of the wave and the glacier collapse. The footage captured by scientists working in the region became a valuable resource, providing insights into the power of these kinds of natural events. But the true impact of the tsunami on Greenland's environment and the larger issue of climate change became a central focus for many experts. This one event acted as a stark reminder that the problems caused by global warming are not just about rising temperatures. They are about the complete disruption of ecosystems, the destruction of landscapes, and the unpredictable chain reactions that can follow. As experts began to analyze the data and the footage of the event, one thing became clear: we are entering a new era of climate risk. Events like the Greenland tsunami are not isolated occurrences, but part of a larger pattern of increasingly extreme weather events and natural disasters. The changing climate is already reshaping the world around us, and as we continue to see more and more of these kinds of events, the importance of taking action to address climate change becomes even more urgent. The impact of the Greenland tsunami serves as a cautionary tale, one that reminds us of the pressing need to tackle the environmental crisis before it's too late. The June 17, 2017, Greenland tsunami was a wake-up call, a stark reminder of the growing dangers of climate change and the powerful forces of nature that we are only beginning to understand. While the destruction caused by the massive wave was extraordinary, the most alarming aspect of the event was the role that the melting glaciers and rising temperatures played in its creation. Greenland, with its vast ice sheet that has been slowly but surely shrinking over the past century, is at the forefront of this global crisis. The event wasn't just an isolated disaster. It was a clear sign of the devastating consequences of climate change. The Greenland tsunami serves as a powerful symbol of what can happen when nature's delicate balance is upset by human activity, particularly the burning of fossil fuels and the unchecked emission of greenhouse gases. Looking forward, it is clear that we need to pay more attention to the effects of glacial collapse and the associated risk of tsunami waves. Although the June 2017 disaster did not result in significant loss of life, the next event could easily take place in a more populated region with far-reaching consequences. The rapid rate at which Greenland's glaciers are melting suggests that tsunamis like the one we witnessed may become more frequent. As the glaciers continue to shed enormous amounts of ice into the sea, the risks of larger, more destructive tsunamis become more apparent. This is especially concerning for low-lying coastal areas around the world, where people are already facing the threat of rising sea levels and storm surges. Communities that live in these vulnerable regions must prepare for the worst and take measures to protect themselves. In addition to preparing for the immediate effects of such events, it is essential that we focus on long-term solutions to mitigate the causes of climate change. Reducing carbon emissions, transitioning to renewable energy sources, and implementing stronger environmental protection policies are all key steps that can help slow the melting of glaciers and the rise in sea levels. By addressing these root causes, we can not only reduce the risks of tsunamis, but also help stabilize the global climate for future generations. The event in Greenland should be seen not just as an isolated disaster, but as part of a larger trend of increasingly extreme weather events, driven by climate change. As we move forward, it's important to remember that the 2017 Greenland tsunami is not just a story of destruction, but also one of resilience and hope. The scientific community has responded to this event with a renewed commitment to studying and understanding the effects of climate change. Researchers are now more focused than ever on developing better tools and technologies to predict glacial calving, monitor sea levels, and warn communities about the potential for future tsunamis. The lessons learned from this event are helping us prepare for similar disasters in the future, but much more needs to be done. Increased funding for climate science, stronger international cooperation, and better disaster preparedness are crucial if we hope to protect vulnerable communities from the full impact of climate change. In conclusion, the 2017 Greenland tsunami is a powerful reminder that we cannot afford to ignore the impacts of climate change any longer. It is a call to action for all of us to do our part in slowing the destruction of our planet and protecting future generations from the devastating consequences of extreme weather events. While the wave that crashed into the Greenland coastline was a breathtaking display of nature's power, it also serves as a sobering warning of what lies ahead if we do not act swiftly and decisively. Let the tsunami be a symbol of change, a symbol that urges us to take responsibility for our environment before it's too late. The question is, will we heed the call? Lake Vostok is one of the most mysterious places on Earth, hidden beneath Antarctica's thick ice sheet. It is the largest of Antarctica's subglacial lakes, sitting nearly 4,000 meters beneath the ice, in a region known as the Southern Pole of Cold. Despite being buried under ice for millions of years, this massive lake remains a body of liquid water, sealed away from the outside world. The existence of Lake Vostok was first suspected in the late 1950s by Russian geographer Andrei Kapitsa. He studied seismic data from the Soviet Antarctic expeditions and noticed something unusual beneath the ice. Over the next few decades, scientists from Russia, Britain, and the United States continued to study the area using radar and satellite technology. Finally, in 1993, a researcher named J.P. Ridley confirmed the presence of the lake using laser altimetry from the ERS-1 satellite. Lake Vostok is massive, roughly the size of Lake Ontario. Unlike other lakes on Earth, it has been completely sealed off from the atmosphere for an estimated 15 to 25 million years. This means that whatever is living in the lake, if anything, is completely isolated from the rest of the planet. Scientists believe that if microbial life exists in this extreme environment, it could help us understand how life might survive in similar conditions on other planets. One of the reasons Lake Vostok has remained liquid for so long is the thick ice above it. The weight of the ice creates immense pressure, lowering the freezing point of water. Additionally, geothermal heat from the Earth's interior provides enough warmth to keep the lake from turning into solid ice. Because of this, Lake Vostok is one of the few places on Earth where water has been trapped in isolation for such an extended period. Despite its isolation, the lake is not completely cut off from the world above. The ice above Lake Vostok slowly moves, and over time, new layers of ice form, while old layers sink deeper. This process could allow for some exchange of materials, but scientists are still studying how this movement affects the lake's ecosystem. The discovery of Lake Vostok raised many questions. What secrets are hidden in its waters? Could there be life thriving in the darkness below? Scientists have worked for decades to find answers, but exploring a lake buried under kilometers of ice is no easy task. As we continue, we will explore how scientists have attempted to reach Lake Vostok, the challenges they have faced, and the controversies surrounding their research. Reaching the Lake Vostok has been one of the most difficult challenges in Antarctic exploration. Scientists knew that drilling through nearly 4,000 meters of solid ice would take years, and the risk of contaminating the pristine lake was a major concern. Researchers had to develop careful drilling methods to avoid introducing modern bacteria or chemicals into the ancient water. The first serious attempt to drill down to the lake began in the 1990s, led by Russian scientists at Vostok Station. Instead of drilling directly into the lake, they first removed ice samples from above it. These ice cores, taken from the upper layers of the glacier, helped scientists learn about Antarctica's climate history and provided clues about what might be in the lake below. However, drilling too deep risked accidentally releasing water from the lake, which could ruin the untouched environment. To prevent contamination, Russian researchers used a special technique called thermal drilling, combined with a kerosene-based antifreeze. While this helped to keep the borehole open, some scientists worried that the chemicals could seep into the lake. The debate over the best way to reach the lake without harming it continued for years, leading to disagreements between research teams from different countries. In February of 2012, after more than 2 decades of careful drilling, the Russian team finally broke through the last layers of ice and reached the lake's surface. However, instead of extracting water immediately, the pressure from below forced lake water up into the borehole, where it quickly froze. This frozen sample provided scientists with their first glimpse of what was hidden in the depths of Lake Vostok. Further analysis of the ice revealed traces of microbial life, suggesting that despite its extreme isolation, Lake Vostok might not be completely lifeless. However, these findings were met with skepticism, as some researchers argued that the microbes could have come from drilling equipment rather than the lake itself. To settle the debate, more samples needed to be collected, but doing so without contaminating the lake remained a challenge. In the next part, we'll look at what scientists discovered in these samples, what they believe could be hiding in the depths of Lake Vostok, and how this research connects to the search for life beyond Earth. The discovery of possible microbial life in Lake Vostok raised an exciting question. Could an ecosystem exist in complete isolation beneath Antarctica's ice? If so, it would mean that life had survived in total darkness, under extreme pressure, and without direct contact with the atmosphere for millions of years. Scientists quickly set to work analyzing the frozen lake water extracted from the borehole. In 2013, Russian researchers announced that they had found genetic material from bacteria that did not match any known species. Some speculated that these microbes might be native to the lake, evolving independently over millions of years. However, the results were met with skepticism, as critics pointed out the possibility of contamination during drilling. To get more definitive answers, further drilling efforts were planned. However, accessing deeper samples while ensuring the lake remained uncontaminated proved to be an enormous challenge. Unlike surface lakes, which receive nutrients from rivers and the atmosphere, Lake Vostok has been cut off from external sources for millions of years. Scientists wondered whether geothermal heat from the Earth's interior could provide enough energy to sustain life. Some researchers suggested that hydrothermal vents on the lakebed might support microbial communities, much like deep-sea vents found in Earth's oceans. These vents release heat and minerals, creating an environment where life could thrive despite the lack of sunlight. If such an ecosystem existed in Lake Vostok, it would be one of the most extreme examples of life adapting to harsh conditions. This research also had implications beyond Earth. Scientists studying icy moons like Europa and Enceladus believe that similar subglacial lakes could exist beneath their frozen surfaces. If life could survive in Lake Vostok, it raised the possibility that extraterrestrial life might exist in the hidden oceans of these distant worlds. Despite these exciting possibilities, access to Lake Vostok remains difficult. The harsh Antarctic conditions make research operations expensive and dangerous, and environmental concerns continue to limit large-scale exploration. However, each new sample provides a small but valuable glimpse into one of the most mysterious and isolated ecosystems on the planet. As we wrap up, we'll explore the latest research efforts, the ongoing debate over how to study the lake responsibly, and what the future may hold for the search for life beneath Antarctica's ice. As research into Lake Vostok continues, scientists remain divided on the best approach to further exploration. The challenge lies in balancing scientific discovery with the need to protect the lake's pristine environment. Given that it has remained untouched for millions of years, even the smallest contamination could alter whatever ecosystems might exist beneath the ice. One proposed solution is to develop cleaner drilling methods, such as using sterile probes that can melt their way through the ice without introducing foreign materials. These probes would be equipped with cameras and instruments to analyze the lake's conditions in real time. However, developing technology that can function under such extreme pressure and temperatures remains a significant obstacle. In recent years, scientists have turned to indirect methods to study the lake's characteristics. Advanced radar mapping has provided a clearer picture of its depth and structure. These studies suggest that Lake Vostok may not be an isolated body of water, but part of a larger subglacial system connected to other hidden lakes beneath the Antarctic ice. This raises new questions about the movement of water beneath the ice sheet and how these lakes might interact. The search for life in Lake Vostok is also ongoing. Some researchers believe that instead of thriving in the open water, any life forms may exist in sediments at the bottom of the lake, where nutrients could accumulate over time. Studying these sediments could reveal not only whether life exists, but also provide insights into Antarctica's ancient climate history. As technology improves, future missions may be able to explore the lake more directly. If researchers can safely retrieve uncontaminated samples, it could change our understanding of how life survives in extreme conditions. These discoveries could have major implications for the search for extraterrestrial life, reinforcing the idea that life may exist in the ice-covered oceans of distant planets and moons. For now, Lake Vostok remains one of Earth's greatest scientific mysteries. Its hidden waters continue to challenge researchers, offering a glimpse into a world untouched by time. As new techniques are developed, the hope is that one day we may finally uncover the secrets locked beneath Antarctica's ice. Imagine if the Ice Age just never happened. No mile-thick glaciers slowly creeping across North America. No frozen tundras covering northern Europe. No massive ice sheets shaping the land we know today. It's a pretty wild thought, but let's think about it. The last major ice age, also known as the last glacial maximum, peaked around 20,000 years ago. At that time, giant ice sheets stretched all the way down into what's now the northern United States. But what if none of that ice ever formed in the first place? To start off, the most obvious thing is the temperature. Without the Ice Age, the Earth would have stayed much warmer overall. That means polar regions like Greenland and Antarctica might never have developed their thick ice caps. Instead of being icy wastelands, they could be covered in forests, grasslands, or even full ecosystems that we usually only see in temperate zones. Arctic wildlife as we know it, polar bears, Arctic foxes, seals, might not exist at all. Their cold climate niches wouldn't be around, so they probably never would have evolved in the first place. Sea levels would also be completely different. During the last ice age, sea levels were over 300 feet lower than they are today because so much of the Earth's water was trapped in ice. If there had never been an ice age, all that water would have stayed in the oceans. That means the coastlines would be farther inland, and entire parts of the world we live on today would be underwater. Places like Florida, the Netherlands, Bangladesh, and even parts of New York City might just be gone. Coastal cities wouldn't exist as we know them. The shape of the land would be different too. Ice is heavy. When glaciers push across the land, they scrape and flatten the surface beneath them, carving valleys, shaping hills, and creating lakes. The Great Lakes in North America, those were carved out by glaciers. No Ice Age, no Great Lakes. Norway's deep fjords carved by glaciers over time would look totally different or maybe wouldn't even be there. A huge portion of the world's iconic landscapes were created by the movement of ice. Without it, Earth might look a lot smoother and maybe even less dramatic in some regions. And then there's the question of how life would have evolved. Ice ages didn't just change the land, they shaped life too. They forced animals and plants to migrate, adapt, or die off. In turn, that pushed evolution in new directions. For humans, it meant developing tools, shelters, and clothing to survive harsh winters. Without that kind of challenge, early humans might have had a totally different path. We might not have spread out across the globe the same way. Maybe certain populations would have stayed where it was warm and never moved north. That could have changed everything from cultures to languages to the entire timeline of human history. That's just scratching the surface of how different things might have been. The world without the Ice Age would be warmer, wetter, and possibly way less recognizable. And that's only the beginning. In the next part, we'll get into some of the scientific debates about whether the Ice Age happened exactly the way we think it did, or if some of the evidence might actually point to something else entirely. Now that we've pictured a world without the Ice Age, let's talk about something that makes this whole idea even more interesting. There's actually a debate among scientists, not about whether the Earth was cold at times, but about how much ice really shaped the planet. Some researchers fully support the classic idea that massive ice sheets rolled over continents and left behind all sorts of physical evidence, but others say, hold on, maybe we're not seeing the full picture. A big part of the traditional Ice Age story comes from landforms. Geologists look at things like U-shaped valleys, drumlins, and moraines. These are land features believed to be shaped by glaciers. They also point to glacial erratics, which are giant rocks found far from their original location, supposedly carried there by ice. But some scientists argue that water, not ice, could have done that too. In places like eastern Washington, there's a theory that catastrophic floods created some of the features we thought were caused by glaciers. The landscape, known as the channeled scablands, was once believed to be carved slowly by ice, but now we know it formed almost overnight from a massive flood caused by a bursting glacial lake. Then there's the ice core data, long cylinders of ice drilled from Antarctica and Greenland. These cores contain layers that trap tiny bits of ancient air, showing things like carbon dioxide levels and temperature shifts. They're like time capsules of Earth's climate. But here's where it gets tricky. Interpreting those layers isn't always straightforward. Some scientists question whether changes in the layers were caused by cold, icy climates or by other forces like volcanic activity, shifting ocean currents or solar cycles. It's not that the cores are wrong, it's just that they might not tell the whole story on their own. And let's not forget tectonic activity. Earth's surface is constantly moving. Mountains rise, oceans spread, and entire continents shift around. Some researchers say that tectonic forces could have caused a lot of the same features we credit to glaciers. For example, if a valley looks like it was carved by ice, could it actually have been formed by fault movement or erosion over millions of years? The idea here isn't that ice ages never happened, it's more that they might not have happened exactly the way we've been told. Science is always evolving, and as new tools and data come in, old theories get challenged, even textbooks have changed over time. What was accepted in the 1970s might be totally different from what we think now. So when we talk about a world without an ice age, it opens the door to more than just a what-if scenario. It invites us to question how much of what we think we know about Earth's past is solid, and how much is still up for debate. In the next part, we'll take this further and look at how life, not just landscapes, could have taken completely different paths if the cold never came. If the ice age never happened, it wouldn't just change the shape of the land, it would completely change the way life evolved, including human life. The cold climate forced animals and early humans to adapt in ways that helped shape modern species. Without that push for survival in harsh, icy environments, evolution might have taken a totally different path. For example, many large mammals we know today, like woolly mammoths, saber-toothed cats, and giant ground sloths, were specially adapted for the ice age. They had thick fur, large bodies to conserve heat, and diets suited for the colder environments. Without an ice age, these animals might have never existed at all. Instead, the planet might have stayed dominated by species better suited for warmer climates, possibly more reptiles, insects, or jungle-adapted mammals. The colder regions wouldn't have developed the tundras and boreal forests we see now, and the ecosystems would have been completely different. Now think about humans. Our ancestors had to survive through extreme conditions during the last ice age, which peaked around 20,000 years ago. That meant building shelters, creating clothing, using fire effectively, and working together in small groups. All of that helped develop early tools, language, and even social systems. Without those challenges, maybe early humans wouldn't have had the same reasons to innovate so quickly. We might not have spread across the globe the same way. Migration routes were shaped by glacial coverage. When sea levels dropped because of the frozen water, it exposed land bridges like the one between Asia and North America. If the ice age never happened, many of those paths wouldn't have existed, and entire continents might have remained unpopulated for much longer. Agriculture also would have been affected. After the ice age ended, temperatures stabilized and large areas of land became perfect for farming. That shift, known as the Neolithic Revolution, changed everything. People stopped hunting and gathering and started planting crops, which led to villages, cities, and civilizations. Without the end of the ice age creating those fertile plains, farming might have started much later, or maybe not at all in some parts of the world. The Earth's climate also influences disease. Cold, dry environments help preserve bodies, but warmer, wetter ones allow bacteria and viruses to spread faster. In a world without an ice age, global health history might look a lot different. Some of the diseases that wiped out ancient populations could have evolved sooner or spread more quickly. In short, without that global freeze, the world would probably be greener and wetter, but maybe less advanced in terms of human development. We'd still be here, but who knows what we'd look like, how we'd live, or what kind of creatures we'd share the planet with. And that brings us to the final part, where we'll explore what the environment and modern world might be like today if the ice age never came. So what would the modern world actually look like if the ice age never happened? Well, to start with, coastlines would be completely different. During the ice age, so much water was trapped in glaciers that sea levels dropped by over 300 feet. When the glaciers melted, that water flowed back into the oceans, raising sea levels and flooding coastlines. Without that process, a lot more land would still be exposed today. Places that are underwater now, like parts of the North Sea or the Bering Strait, might still be dry land, connecting continents and creating entirely different maps. The weather patterns would also be nothing like what we know. Ice ages help regulate Earth's long-term climate by pushing cold air toward the equator and creating stable seasonal changes. Without that massive freeze and thaw cycle, weather systems might be more extreme and unpredictable. We could be looking at hotter tropics stretching further north and south, with fewer areas that experience regular seasons. The polar regions might still be chilly but not nearly as icy, which would mean less reflection of sunlight back into space. That change in sunlight absorption could have made Earth warmer overall. Glaciers also play a big role in shaping rivers and lakes. A lot of the world's most important freshwater sources, like the Great Lakes in North America or many rivers in Europe, were carved out by glaciers. If those glaciers never existed, it's possible that many of our freshwater supplies would be smaller or not there at all. That could have changed where people settled, which cities were built, and how civilizations grew over time. Even mineral resources would be different. Glacial movements helped scrape and expose metal-rich rock formations, making it easier for humans to mine things like iron, copper, and gold. Without glaciers doing that work, early societies might have had a harder time accessing those materials, which could have slowed down the development of tools, buildings, and trade. Modern agriculture would be another major difference. The melting of glaciers after the Ice Age left behind nutrient-rich soil, perfect for growing crops. Without that, much of the land we now use for farming might have been less productive. Countries that depend on agriculture today might have looked completely different or struggled to develop large-scale farming at all. Finally, tourism, sports, and recreation tied to snow and ice, like skiing, snowboarding, or glacier hikes, probably wouldn't even exist. Some of the world's most visited natural wonders, like Norway's fjords or the glaciers in Alaska and Patagonia, wouldn't have formed at all. Landscapes would be smoother, flatter, and maybe less dramatic. So, yeah, if the Ice Age never happened, we'd be living on a very different planet. The land, the weather, the animals, even human life would all have taken a different path. It's wild to think that a few degrees of global cooling thousands of years ago ended up shaping almost everything we see around us today. Yeah, thanks for sticking around for this thought experiment. If you're into more mind-bending stuff like this, check out our playlist on hypothetical scenarios. Could humans realistically colonize Antarctica by the year 2050? It's a wild idea, but with climate change, population growth, and advancements in technology, some believe it's worth considering. Antarctica is the last truly untouched frontier on Earth, a continent larger than Europe, covered in ice, and home to some of the most extreme conditions known to humankind. While it has long been a place for scientific research, the idea of permanent human settlement raises many questions. Some practical, some ethical, and some that push the boundaries of what we consider possible. Before diving into how colonization could happen, it's important to understand why anyone would even consider it. As global temperatures rise, Antarctica's ice sheets are changing, and while it remains an inhospitable environment, the idea of humans establishing a foothold there is becoming less impossible. Some believe that in the coming decades, Antarctica could hold new opportunities, from untapped resources to scientific discoveries, making it a place of interest for future expansion. But this is not just about finding space for people to live. Unlike other remote places humans have settled, Antarctica is governed by international agreements that protect its environment and limit human activity to research and conservation. The Antarctic Treaty, which has been in place since the year 1961, prevents any country from claiming land or exploiting resources there. While this treaty currently blocks colonization, future political shifts or new global challenges could bring changes to these rules. At the same time, there's a question of whether we even have the technology to make life possible in such an extreme place. Current research stations operate on limited supplies, relying on outside support to function. The temperatures can drop far below freezing, and the continent experiences months of total darkness during winter. Any attempt at colonization would require technology far beyond what we currently use in temporary research bases. There's also an ethical debate surrounding whether humans should even attempt to live there. Antarctica is one of the most fragile ecosystems on the planet, and human activity, even in small amounts, has already had an impact. Could a colony exist without destroying the very landscape that makes it so unique? The question of whether humans could colonize Antarctica by the year 2050 is not just about survival. It's about whether it's worth doing at all. With so many obstacles, both natural and political, the road to making it happen would be anything but easy. One of the biggest obstacles to colonizing Antarctica is not just surviving the brutal cold, but also building infrastructure that can sustain human life long term. Right now, the only people living on the continent are scientists and support staff at research stations, and even they don't stay year-round in most cases. Their facilities are heavily insulated, built to withstand extreme weather, and rely on regular supply shipments from their home countries. A permanent colony would need to take this concept much further, designing structures that could handle Antarctica's climate without constant outside assistance. Renewable energy would likely be the backbone of any Antarctic settlement. With nearly constant daylight during the summer months, solar power could provide energy for heating and electricity. Wind power is another possibility, as the continent experiences some of the strongest winds on the planet. However, the long, dark winters would make energy storage a major challenge. Colonists would need advanced battery technology or alternative energy sources to survive through the months when sunlight is non-existent and temperatures are at their lowest. Another critical concern is food production. Transporting food to Antarctica would be expensive and unreliable, so a colony would need to find ways to grow its own food despite the lack of soil and harsh climate. Hydroponics and vertical farming could be solutions, allowing crops to be grown indoors using nutrient-rich water instead of soil. Some experiments with this technology have already been conducted at Antarctic research stations, with limited success. However, scaling up these methods to feed a large population would require significant innovation. Even if shelter and food could be managed, maintaining human health in such an isolated and extreme environment would be difficult. The cold and dryness of Antarctica can cause serious health problems, including respiratory issues and weakened immune systems. Medical facilities would need to be fully equipped to handle emergencies, as transporting patients to hospitals outside the continent could take days or even weeks in bad weather. Mental health would also be a concern, as the isolation, darkness, and extreme conditions could take a psychological toll on settlers. Despite these challenges, some experts believe that with the right technological advancements and international cooperation, a small human settlement could be possible by the year 2050. The question is whether the benefits of colonizing Antarctica would outweigh the risks and costs involved. If humans were to colonize Antarctica by the year 2050, one of the most critical factors to consider would be sustainability. Unlike space colonies or even remote Arctic settlements, an Antarctic colony would have to exist in one of the most fragile ecosystems on Earth. Any mistake in managing waste, energy, or food production could have long-term consequences for both the environment and the survival of the colony itself. Water supply would be a major issue. While Antarctica holds the majority of the world's fresh water, almost all of it is locked in ice. Melting ice for drinking water would require a massive energy investment, and colonies would need to ensure that their water usage remains sustainable. Some research stations currently rely on desalination of seawater, but this method is costly and energy intensive. If a settlement were to grow, it would need efficient water recycling systems to minimize waste. Waste management would be just as important. Antarctica's extreme cold slows down decomposition, meaning waste could accumulate quickly if not properly handled. Any long-term colony would need strict recycling programs and possibly incineration systems to manage garbage without polluting the environment. Human waste disposal would also be a challenge, as traditional sewage systems would not function properly in frozen ground. Research stations today use special containment systems to collect waste and remove it from the continent, but a permanent settlement might need to develop new methods to process waste on site. Another major concern is transportation. Colonists would need a way to move across the ice-covered landscape efficiently, whether for scientific exploration, resource gathering, or emergency evacuations. Traditional vehicles struggle with the extreme conditions, and even tracked snow machines require constant maintenance. A possible solution could be the use of autonomous vehicles powered by renewable energy, reducing the need for human exposure to dangerous conditions. Some experts have also suggested the development of underground tunnels or enclosed walkways to allow movement between buildings without exposing people to the elements. International politics would also play a key role in whether Antarctica could be colonized. The Antarctic Treaty currently prohibits territorial claims and permanent human settlements, meaning any large-scale human presence would require major legal changes. Countries might disagree on who would control resources, how land should be used, and how environmental protections should be maintained. Without cooperation, the dream of colonization could be impossible, as competing nations could turn the continent into a political battleground. As discussions around Antarctic colonization continue, the question remains, could all these technological and political hurdles be overcome by the year 2050? If so, what kind of society would exist there? The answers are uncertain, but one thing is clear: any attempt to colonize Antarctica would have to be one of the most carefully planned human endeavors in history. If humans were to establish a permanent colony in Antarctica, by the year 2050, the final and perhaps most critical question would be, how would people actually live there long term? Unlike research stations where scientists rotate in and out, a true colony would require infrastructure to support families, schools, businesses, and everyday life. One of the biggest considerations would be housing. Buildings in Antarctica would need to be highly insulated, capable of withstanding extreme cold and high winds, and designed to function with minimal external support. Traditional construction materials like wood and concrete would not be ideal due to the harsh conditions, so advanced materials such as aerogels, carbon fiber composites, and specially designed thermal-resistant polymers could be necessary. Some experts suggest modular, dome-shaped structures that could be expanded over time and connected through enclosed walkways to protect residents from the elements. Energy production would also be crucial for survival. While current Antarctic research stations mostly rely on diesel fuel, this method is costly, difficult to transport, and environmentally harmful. A future colony would likely need to rely on a combination of renewable energy sources such as wind, solar, and possibly even geothermal power if heat sources could be accessed beneath the ice. With the Antarctic summer providing months of continuous sunlight, solar power could be a major asset, while wind energy could generate power during the long, dark winters. Food production would present another challenge. Importing food would be expensive and unsustainable for a large colony, so settlers would need to find ways to grow their own food in an environment where traditional farming is impossible. Hydroponics and vertical farming, already being tested in some Antarctic research stations, could be expanded on a much larger scale. These controlled indoor farms would allow colonists to grow fresh vegetables, fruits, and even protein sources like algae and lab-grown meat. Scientists are also exploring the possibility of using genetically modified crops that could thrive in cold, low-light conditions. A long-term Antarctic colony would also require healthcare facilities equipped to handle everything from common illnesses to medical emergencies. In such an isolated environment, hospitals would need to be largely self-sufficient, with advanced diagnostic tools and even robotics surgical systems in case of critical medical situations. Mental health would also be a major concern, as prolonged isolation, extreme weather, and the psychological impact of living in an enclosed environment could take a toll on residents. Strategies such as regular virtual contact with the outside world, entertainment options, and carefully planned community activities would be essential to maintaining morale. Despite all these challenges, some experts believe that colonizing Antarctica could provide valuable insights for future space colonization. The extreme environment of the continent shares similarities with conditions on Mars or the Moon, making it a perfect testing ground for off-world settlements. If humans can successfully build a self-sustaining colony in Antarctica, it could be a stepping stone toward humanity's expansion beyond Earth. Whether or not a permanent Antarctic settlement becomes a reality by the year 2050 remains to be seen. The obstacles are enormous, but with rapid advancements in technology, shifting global priorities, and the increasing need for alternative living spaces, the idea is not as far-fetched as it once seemed. The future of human colonization on Earth and beyond may very well begin on the icy frontier of Antarctica. Imagine looking at the news and seeing that Antarctica's vast ice sheets, stretching across millions of square kilometers, have vanished overnight. The sheer thought is enough to send chills down your spine, but it's also a hypothetical that highlights the fragility of our planet. Antarctica holds about 60% of the world's freshwater, locked away in its ice sheets. If all that ice disappeared in an instant, global sea levels would surge by over 58 meters, swallowing coastal cities and radically reshaping continents. This sudden event would plunge the world into chaos, starting with immediate flooding. Major cities like New York, London, Tokyo, and Sydney would be submerged underwater. Entire island nations, including the Maldives and Tuvalu, would cease to exist. Coastal regions that support hundreds of millions of people would become uninhabitable within hours. Ports, trade hubs, and airports located near shorelines would be underwater, effectively cutting off vital supply chains and triggering a domino effect of economic collapse. The immediate human cost would be staggering. Hundreds of millions of people would lose their homes in a single night, becoming climate refugees with nowhere to go. countries already grappling with overcrowding or economic hardship would face insurmountable challenges trying to absorb such a massive influx of displaced populations. The resulting humanitarian crisis would dwarf anything the world has ever seen, putting unbearable strain on international resources and cooperation. In addition to the destruction of coastal infrastructure, the sudden disappearance of Antarctica's ice sheets would wreak havoc on global weather patterns. Ice plays a critical role in regulating the planet's temperature by reflecting sunlight back into space. Without it, Earth's natural cooling system would fail, causing a rapid increase in global temperatures. This albedo effect, as scientists call it, would accelerate warming, making extreme weather events like hurricanes, droughts, and heat waves more frequent and intense. Rivers, lakes, and other freshwater sources would also face contamination from saltwater intrusion, making clean drinking water scarce in many parts of the world. Crops near coastlines would be destroyed, and fertile farmland could turn into salty wastelands. This would jeopardize global food security, driving up prices, and leading to widespread hunger and political instability. The impact wouldn't just stop at sea level rise and flooding. Antarctica's ice sheets also serve as a stabilizing force for Earth's tectonic plates. Their immense weight keeps the crust in balance. If that weight suddenly disappeared, it could trigger a cascade of seismic activity. Earthquakes and volcanic eruptions in regions near tectonic boundaries, such as the Pacific Ring of Fire, could become far more frequent, adding another layer of devastation to an already catastrophic scenario. The scale of destruction would be unimaginable, touching every aspect of life on Earth. This what if may sound like science fiction, but it underscores the very real consequences of ignoring climate change. In the next part, we'll explore the forces driving ice loss in Antarctica and how close we are to tipping the scales toward this apocalyptic reality. While the idea of Antarctica's ice sheets vanishing overnight may seem impossible, the forces driving ice loss are already in motion. To understand the threat, we need to examine the complex interactions between rising global temperatures, shifting ocean currents, and the delicate balance that has kept Antarctica's ice stable for millions of years. This part of the story focuses on what's fueling this slow-motion crisis and why the situation is more urgent than it appears. At the heart of Antarctica's ice loss is climate change, driven by the release of greenhouse gases like carbon dioxide and methane into the atmosphere. Since the beginning of the Industrial Revolution in the late 1700s, human activity has increased these gases to levels not seen in over 800,000 years. As a result, global temperatures have risen by more than 1 degree Celsius since the late 19th century, with significant consequences for polar regions. Antarctica's vulnerability lies in its geography. The continent is surrounded by a vast ocean, and its ice sheets sit atop both land and water. Warmer air temperatures are melting ice from above, but the more dangerous threat comes from below. Ocean currents, altered by climate change, are bringing warmer water into contact with the base of Antarctica's ice shelves. These shelves act as barriers, holding back the massive ice sheets behind them. When they weaken or collapse, the ice sheets can flow into the ocean, raising sea levels. One of the most alarming examples is the Thwaites Glacier, often called the Doomsday Glacier. Located in West Antarctica, it's roughly the size of the state of Florida and holds enough ice to raise global sea levels by over 3 meters if it collapses. In recent decades, the glacier has been losing ice at an accelerating rate due to warm water melting its underside. Scientists estimate that its collapse could begin within the next few decades if current trends continue. Beyond individual glaciers, Antarctica's ice sheets are destabilized by a feedback loop. As ice melts, it reduces the reflective surface area that bounces sunlight back into space, a phenomenon known as the albedo effect. Darker ocean water absorbs more heat, causing further warming and more melting. This self-reinforcing cycle means that once significant melting begins, it becomes increasingly difficult to slow down or reverse. Another factor compounding the crisis is the breakdown of ocean circulation systems, particularly the Antarctic Circumpolar Current. This powerful flow of water around the continent acts as a buffer, isolating cold Antarctic waters from warmer currents. However, as ice melts and fresh water enters the ocean, it disrupts this delicate balance. Changes in salinity and temperature weaken the current, allowing warmer water to infiltrate and accelerate melting even further. The potential for runaway melting isn't just a distant possibility, it's already visible in some regions. The Amundsen Sea, for example, has seen some of the most rapid ice loss in Antarctica, with several glaciers thinning by up to 9 meters annually. This rapid pace shows that large-scale ice loss can occur much faster than previously believed, raising concerns about how prepared humanity is for such an event. These complex dynamics reveal that Antarctica's ice sheets are not just melting, they're unraveling due to a perfect storm of climate-related factors. The situation is further complicated by the fact that much of the melting occurs in remote and inaccessible areas, making it challenging for scientists to fully monitor or predict the pace of change. Yet the warning signs are clear. Antarctica's ice sheets are approaching a tipping point, and their fate hinges on global actions to curb greenhouse gas emissions. In the next part, we'll delve into the ripple effects that this hypothetical collapse would unleash across ecosystems, economies, and societies worldwide. The impacts would extend far beyond rising sea levels, transforming the planet in ways we might not fully comprehend until it's too late. If Antarctica's ice sheets were to vanish overnight, the immediate aftermath would be catastrophic on a global scale. The most obvious and devastating consequence would be the dramatic rise in sea levels. Scientists estimate that the complete melting of Antarctica's ice could add roughly 60 meters to global sea levels. This would inundate major coastal cities such as New York, London, Tokyo, and Sydney, leaving vast regions underwater and displacing hundreds of millions of people almost instantly. The loss of Antarctica's ice would also create a domino effect across global ecosystems. Coastal wetlands, which act as natural buffers against storms and provide critical habitats for numerous species, would be submerged. These ecosystems are home to birds, fish, and countless other organisms that rely on the delicate balance of salinity and tidal patterns. Their disappearance would disrupt food chains and lead to a decline in biodiversity that could take centuries to recover. Marine ecosystems would also face significant disruption. The cold, nutrient-rich waters surrounding Antarctica play a critical role in supporting life across the Southern Ocean. These waters fuel the base of the food chain, sustaining krill populations that are essential to whales, seals, and seabirds. Without the ice sheets to regulate ocean temperatures and maintain the flow of nutrients, the entire marine ecosystem in the region could collapse, triggering a ripple effect through global fisheries and food supplies. Beyond ecological damage, the vanishing of Antarctica's ice would have profound effects on global weather patterns. The massive ice sheets act as stabilizers for the planet's climate system. Their loss would disrupt atmospheric circulation, leading to more extreme and unpredictable weather events worldwide. Hurricanes and typhoons could become more powerful due to warmer oceans, while prolonged droughts and heat waves would threaten water supplies and agricultural yields in many regions. The sudden addition of trillions of tons of fresh water to the oceans would also disrupt thermohaline circulation, a critical component of the Earth's climate system. This global conveyor belt of ocean currents distributes heat around the planet, moderating temperatures and driving weather systems. If disrupted, regions such as Europe could experience severe cooling despite overall global warming, while other areas like the tropics could become unbearably hot. Economically, the effects of such an event would be staggering. Coastal infrastructure worth trillions of dollars, including ports, power plants, and urban centers, would be lost. Insurance industries would collapse under the weight of unmanageable claims, and governments would struggle to rebuild or relocate entire cities. Global trade would grind to a halt as supply chains heavily reliant on coastal infrastructure are thrown into chaos. The humanitarian crisis would be unprecedented. Hundreds of millions of people living in low-lying areas, from Bangladesh to the Netherlands, would be forced to flee their homes. Refugee numbers would dwarf anything seen in history, straining resources and political systems worldwide. Competition for dwindling resources such as fresh water, arable land, and food could ignite conflicts, further destabilizing already vulnerable regions. Compounding these challenges is the potential release of ancient carbon stores currently trapped beneath Antarctica's ice. As the ice sheets vanish, vast amounts of frozen organic material could thaw and decompose, releasing methane and carbon dioxide into the atmosphere. This feedback loop would accelerate global warming, amplifying the crisis and making recovery even more difficult. The immediate and far-reaching consequences of this hypothetical event highlight how interconnected our planet's systems are. The loss of Antarctica's ice would not only reshape the physical geography of the Earth, but also challenge humanity's ability to adapt and survive in a dramatically altered world. In the final part, We'll explore what actions can still be taken to prevent such a scenario and how the lessons of today could shape the future of the planet. If the ice sheets of Antarctica were to vanish overnight, the aftermath would serve as a grim wake-up call for humanity, revealing both the fragility of our planet and the urgency of collective action. Such a monumental event would leave no aspect of life untouched, forcing humanity to confront the profound consequences of a dramatically altered Earth. One of the most daunting challenges in the wake of this disaster would be global displacement. Entire nations such as the Maldives and Tuvalu would cease to exist beneath rising waters, and countless coastal cities around the world would become uninhabitable. This would trigger the largest migration crisis in human history. Governments and international organizations would face the unprecedented task of resettling hundreds of millions of refugees, requiring new infrastructure, housing, and resources in already crowded and resource-strained regions. Without coordinated global efforts, competition for survival could lead to widespread unrest and geopolitical instability. In addition to displacement, the loss of Antarctica's ice would have irreversible effects on agriculture and global food security. Fertile farmland would be destroyed by saltwater intrusion as rising seas contaminate soil and freshwater sources. Coastal fisheries, already under pressure, would collapse due to ecosystem disruptions and changes in ocean temperature. Crops dependent on stable climates would struggle to adapt to extreme weather patterns, leading to food shortages and skyrocketing prices. Global hunger and malnutrition would become widespread, hitting vulnerable populations the hardest. The crisis would also lay bare the inequities in the world's ability to respond to such a catastrophe. Wealthier nations with more resources might adapt more easily by building seawalls, relocating infrastructure, and developing advanced technologies. However, poorer countries, often those contributing the least to global emissions, would bear the brunt of the devastation. Entire cultures, histories, and ways of life would be at risk of disappearing forever, highlighting the disproportionate burden carried by those least responsible for climate change. As the world grapples with these challenges, humanity would be forced to reconsider its relationship with the planet. A crisis of this scale would likely accelerate scientific innovation and global collaboration as societies unite to find solutions. Renewable energy technology would become an urgent focus, as reducing greenhouse gas emissions would be critical to preventing further climate catastrophes. Countries would have to move beyond short-term interests and work together to rebuild, adapt, and create systems capable of withstanding the new realities of a transformed planet. Furthermore, the disappearance of Antarctica's ice would offer valuable lessons about the long-term consequences of inaction. It would serve as an undeniable demonstration of how interconnected the planet's systems are and how deeply human activity impacts the natural world. This newfound awareness could inspire future generations to prioritize sustainability, conservation, and environmental stewardship in ways that have previously been neglected. The catastrophic loss of Antarctica's ice would also force a reckoning with humanity's role as caretakers of the Earth. It would demand a shift in mindset from exploiting resources for short-term gain to protecting the planet for future generations. The world would need to develop policies that prioritize resilience and equity, ensuring that no region or community is left behind in the effort to rebuild. In the end, this hypothetical scenario is a sobering reminder of what's at stake if we fail to act. Antarctica's ice sheets are not just a distant feature of the Earth. They are a cornerstone of the planet's stability. While the idea of them vanishing overnight is extreme, the ongoing and rapid loss of ice is a reality we must confront. By taking action now, humanity has the opportunity to mitigate the worst outcomes, protect vulnerable populations, and chart a course toward a more sustainable and equitable future. The choices we make today will shape the planet for generations to come, whether through renewable energy, conservation, or international collaboration. The steps we take can help ensure that the dire consequences of this scenario remain in the realm of what if rather than becoming our reality. Icebergs are huge pieces of freshwater ice that break off from glaciers or ice shelves and float in open water. Most icebergs form in places like Antarctica and Greenland, where massive sheets of ice stretch out into the sea. When a chunk of this ice breaks away, it becomes an iceberg. This process is called calving, and it happens naturally as the edge of a glacier moves forward and becomes unstable. And once in the ocean, icebergs start drifting. Their movement is mainly controlled by ocean currents, winds, and tides. These forces push icebergs away from their origin and can carry them hundreds or even thousands of miles. Some icebergs stay far out in the ocean and slowly melt away over time, but others take a different path. They move into shallower coastal waters, getting closer and closer to land. Not all icebergs make it that far. Many break apart or melt before reaching the coast, but the larger ones, some as tall as buildings and as wide as city blocks, can last for months or even years. These giants can eventually run into underwater ridges or shorelines. When this happens, the collision can be intense, especially if the iceberg is still mostly intact and moving with speed. The chance of an iceberg hitting land depends on where it forms and the currents it follows. Along the coasts of Canada, Greenland, and parts of Antarctica, iceberg landings are more common. In some areas, people keep a close watch on iceberg movements to avoid accidents, especially where shipping routes are nearby. When an iceberg finally reaches land, the result can be dramatic. These frozen masses, some weighing millions of tons, move slowly but with enormous force. Even at a few knots of speed, the sheer size and weight of an iceberg can cause serious impact when it meets solid ground. The collision usually starts beneath the surface, where most of the iceberg's mass is hidden underwater. Nearly 90% of an iceberg sits below the waterline, so the contact with the seabed or coastal terrain begins before anything is seen above. As the underwater base scrapes or slams into the shore or a submerged slope, the iceberg can grind to a halt. This creates a loud, deep rumbling that sometimes feels like a small earthquake. The pressure can tear away chunks of the seabed, disturb marine ecosystems, and stir up sediment that has been resting for centuries. In shallower waters, this process can even reshape parts of the coastline. Above water, the collision can cause ice to break off in large chunks. Pieces the size of trucks or houses may split and fall into the sea. This often triggers sudden waves, which can be dangerous for nearby boats or structures. In remote regions like Greenland or the Antarctic coast, these waves might go unnoticed, but in areas closer to human activity, the surges can damage docks, fishing equipment, or even buildings near the shoreline. In some cases, if the front of the iceberg is pushed upward against land, it may tilt or roll. This can create even larger waves and send ice debris flying. While rare, these rollovers are powerful and can pose a threat to ships or coastal stations monitoring ice movement. Once an iceberg is grounded, it may stay lodged in place for weeks or even months, slowly melting or breaking apart as weather conditions change. Once an iceberg has collided with land and come to a stop, the environmental changes begin to unfold over time. One of the most noticeable long-term effects is coastal erosion. As the iceberg melts, the runoff from fresh water can destabilize nearby soil and rock, slowly wearing away the land. In areas with permafrost or fragile coastal shelves, this can lead to landslides or cliff collapses over weeks or months. Another effect is the sudden change in salinity in the surrounding ocean water. Icebergs are made of fresh water, and as they melt, they release huge volumes into the saltwater environment. This can upset the balance of local marine ecosystems. Species that rely on stable salinity levels may be forced to migrate, while others might not survive the shift. In places like the North Atlantic and around Antarctica, these disruptions have been linked to changes in fish populations and plankton growth. The release of sediments is another concern. When an iceberg scrapes along the ocean floor before hitting land, it stirs up mud, sand, and ancient debris buried beneath. As the iceberg rests and melts, this material can be deposited along the shoreline, altering habitats and sometimes burying smaller ecosystems. In some regions, this process has even reshaped tidal zones and shallow bays. There's also a chain reaction in the local food web. As certain fish or crustaceans move away due to habitat loss or water changes, animals that feed on them like seabirds or seals may begin to struggle. These ripple effects can last for years, depending on the size of the iceberg and the sensitivity of the environment it impacts. Finally, iceberg collisions can influence local climate patterns. Large icebergs absorb and reflect sunlight differently than open ocean or land. When grounded near a coast, they can slightly cool the nearby area. This can delay seasonal ice melt or shift wind and weather conditions along that coast. Over the past century, there have been several recorded cases of icebergs colliding with land, especially in polar regions and remote coastal zones. One notable example occurred in the early 20th century when a large tabular iceberg broke off from Antarctica and grounded near South Georgia Island. The massive chunk of ice disrupted local wildlife, blocked ship routes, and took years to fully melt away. Events like this have helped researchers understand just how disruptive iceberg groundings can be. In recent years, the iceberg known as A68, which calved from Antarctica in 2017, gained global attention as it drifted dangerously close to South Georgia Island in 2020. Although it narrowly avoided direct landfall, its approach alone stirred international concern due to the threat it posed to fragile ecosystems and global shipping lanes. Today, scientists use satellite tracking, radar, and ocean buoys to keep a close eye on iceberg movement. Organizations like the U.S. National Ice Center and the European Space Agency monitor large icebergs in real time. These systems help predict where an iceberg might go, how fast it's moving, and whether it's likely to hit land. This kind of information is vital for researchers, coastal planners, and even fishing operations in the Arctic and Antarctic regions. Scientists also study the structure and thickness of icebergs to understand how they'll behave if they reach shallow waters or make landfall. Icebergs that have been weakened by warmer ocean currents tend to break apart more easily, reducing the chance of a dramatic impact. But with rising global temperatures, more frequent and unpredictable iceberg calving events could increase the chances of land collisions in the future. Looking ahead, climate change could make these collisions more common. As polar ice sheets continue to melt, more large icebergs are breaking away and entering shipping routes or drifting toward populated coastlines. While most melt harmlessly at sea, a small number still make contact with land, especially in places like Greenland, parts of Canada, and the southern Atlantic islands. Ultimately, iceberg collisions with land are rare but powerful events. Through technology and ongoing research, scientists hope to stay ahead of these natural forces and minimize their potential impact on both human activity and the environment.